Well, hi, good morning. Thank you for joining me here. It's May 12th, and the sun is shining outside, but I'm in my shop here this morning. So, yesterday, in trying to figure out what might have caused this resistor to overheat, I did a test which suggested the filter capacitor was shorted. At least one of the three sections, the one that's connected directly to the resistor, is shorted. That's a little far-fetched. It's possible, of course. Almost anything's possible, but it's not very likely. So probably my measurement was false. I'm going to look into that to start off with. Was that really a valid measurement? So one of the things we can do right away is take a look. At least I'll be able to see it. Wow, it's quite visible. It's right here. It's right in the open. Okay, and there was one wire coming down from the resistor, kind of a yellow stripe, yellow-red stripe. The striping is reddish. So I'm pretty sure I see it coming to the capacitor terminal back here. I wanted to see was, is there anything else? Yes, there's another wire connected to it, a red wire. Comes around right here. Connects to a terminal which appears to come right out of the circuit board. But wow. What I'm looking at here, looking right down here, that. Be careful how I'm supporting this radio here. So I think the idea of a shorted capacitor, that's kind of far-fetched. I'm going to put this down on its antenna. Okay. Spiders from days gone by. Oh, we see this funny little deal here, which I'm not sure what to make of. And somewhere there should have been, I should have found by now, a solid state rectifier, which I have not noticed yet. It's a little strange. What's going on right there? Let me bring out the other camera here. Just give the autofocus a moment. Well, that is definitely odd. They would solder two wires together and just leave them hanging, especially one of them is bare and it's practically in contact here. Well, maybe it's not bare. Another job for the fish knife here. Well, I think that's bare metal. Yeah, fish knife says that is bare metal. What are they doing? I have no idea if this has any bearing on the burned up resistor or overheated resistor, but this is an odd thing, and it's virtually in contact there. It's very odd. Radio manufacturers don't leave things laying around like that. Not the best looking solder job, but somebody soldered this right onto the chassis, which is a challenge because it's hard to heat up a large bit of metal. What are those? Those speaker connections, so we don't have to worry about that. So one side speaker is grounded. One side of the speaker is just grounded. Okay. Well, where's this black wire coming from? It's going underneath the... Probably not going to be able to see it here because it's down under. So the wire is over here. So you kind of see my finger wiggling in the corner. That's where the wire is. And the wire it seems to just go underneath the transformer and then disappear. Wait a minute, I can see it here myself. Just get down on my hands and knees and look. Whoop. It must go into the windings of the transformer here. That's where I just wish I could get a direct look at it. So now there's two other wires coming out of there, a red and a green one. And what's the black one? Black often means something special, like a ground or something. And that's why they just leave this bare here, because they didn't really care if it grounded out. That's possible. That could easily be what happened here. It still is odd they solder two wires together and leave them just floating like that. That's really... this is kind of odd too. What's with this? I mean, manufacturers don't rely on tape. This is... it feels like friction tape here. Which is actually, from my experience, it's actually pretty good tape to use. Just having a little bit of trouble getting around and looking up this way. Again, I really don't know what to expect to see. Come on, camera. My camera's not cooperating. So I think there's something inside that wrap of stuff. See, it's the same green wire now that's coming from the mystery connection over here. No, it's not a green wire, it's a red wire. It comes from the mystery connection. Well, I don't know. I'm just sort of fishing here. Okay, enough concern about a bare wire. Let's take a look. Oh, I got the camera. I might as well take a look at this. So if you look at the surface of the capacitor, it may actually be the bottom of the capacitor. It's kind of crumpled up there a little bit. That might indicate some kind of a leak or drying out of the capacitor, but the main thing is its age. Oh, I was wondering where the diode was, and look at this thing. This thing is actually shaped like its symbol. This is the diode right here. Right here. Oh my gosh, so coming out of this, is the high voltage. Okay. Well, this fishing expedition isn't doing very well. So I think if I want to prove this capacitor to be good, how can I do this without doing anything too extreme? There's 2 wires off the back terminal. There's 2 wires off of every terminal. 3 off of that one. I just doubt that this capacitor is the problem. But I need to prove it somehow. How do you do that? Can you do that with it in the circuit? What if I apply an alternate source of high voltage? The high voltage is on this terminal. Maybe I can deduce what that terminal really is back there. If I look at the schematic, because I know where this one is now. And can't really. Yeah, well, I know one of the 3 terminals. Let's look at the schematic here. Unfortunately, I made a video error and just did a section without recording anything, so I'm going to have to redo this. So this is what I was just telling you, but you didn't hear. Here's the 3-section capacitor. Here's the resistor. This is the one I believe has burned up. Here's the diode. There's the connection I can see to here. So I can tell which terminal this is on the 3-terminal capacitor. All I got to do is get out my ohm meter and look for 1,000 ohms, and I'll have this terminal. If I read 2,000, then I'm reading through these 2 over to here. I also wondered, is there another capacitor on this line that could have shorted that would cause the resistor to burn? And everywhere I looked, there was resistors. There's no capacitor to ground as I had hoped, because then it would be easy to explain. But see, there's a resistor in every direction on that wire, except this capacitor here, which again I just think is unlikely to. It's unlikely, but who knows. So I'll take those tests. I will identify this from that wire and then read the other 2. I think I know which one is this already. And we'll see if I get 1,000, and the resistor itself appears to have gone high, 1,300 if I remember right, 1,400. So maybe that's what I'm going to read here. So basically it's the lower resistance of these 2 will identify this one. And then I can check to see if this is shorted here to ground. The idea being it's this short that's pulling current through the resistor here. Hey, wait a minute. What about up this way? Could you pull current up through it this way? Like if this were shorted to ground, but it's not going to ground. I'm not sure about that. Offhand, I don't think so. Like a short in this, I don't think it's gonna work that way. It's almost 213, 237, almost the same voltage. They're just kind of across the thing here. Yeah, the thing. Okay, let's do the test. Okay, once again, I'm going to use the Allen meter. Thank you, Allen, for sending me this meter quite some time ago. Okay. So we're looking between the terminals of the capacitor here, even though it's all in circuit still. It's this one versus the other. We should see. What was the value I was looking for? Overload. So it was 1,000 ohms. One of them I read at 1,300, and the other one I haven't read, so I'm guessing it's 1,000. You put those together, you get 2,300. So if I go over here and get 13, there we are. So I've now identified positively which terminal is which in this arrangement down here. So this one, if we read it just to the chassis here, get the resistor. It's like the other side of the resistor is grounded. That's not what I was expecting at all. Let's just check all these terminals. There's a ground on here. This is the main high voltage. And it's only showing, what, 38 ohms? That can't be right. .38 ohms, and there's 3 wires connected to it. One of them is a wire going into this output transformer. So one of the things that can happen to radios to bring them to an end is a short circuit in the output transformer. I'm not saying that's what's here. Don't know at all. What's the next step? What is the next step? The next step is to do that measurement again before committing to it. So, yeah, definitely 38 ohms. What about this guy? So here's a wire coming out, and it's ending right here. So I can go right across the diode. Well, that doesn't look good at all. The diode failed? Wow. I have a failed diode. Well, that's easy enough to prove and easy enough to replace. Also, as if I didn't prove it already. Let's see if we can get the hockey tape off here. My experience with this, what's commonly called friction tape, or here in Canada we tend to call it hockey tape. This stuff really works good. Better than the standard electrical tape, the vinyl tape that we're used to. This stuff goes on, stays on, doesn't unwrap, doesn't dry out. It becomes very hard in the long run. This stuff's not very hard here. It becomes very, very hard. I don't want to cut the wire, just cut the tape. I'm really yanking on these wires here. Once again, this is just not the normal thing that you see in radios, at least my experience. This kind of thing, floating connections, not normally done. Normally they would put in some kind of terminal here. They would find some way to put this on a terminal. Okay, so we're going to nip this off. Just solder it all back on later. It turns out there's nothing wrong here. Okay. Huh. You should not read 0 in any direction on a diode like this. The diode is fried. Notice the diode failed, but the tubes are still okay. We get virtually the same reading in both directions. Virtual 0 in both directions. This is probably the problem right here. Yeah, exactly why that would make the resistor fry, I don't know. Maybe if we looked at the schematic, I'd figure it out, but I'm not going to worry about it. We're going to replace this. We will look at the schematic and see what it says about it. Well, now that we're looking at it, let's consider how this could happen. So if this guy shorts, I don't know what to say. I still don't understand what's going on here. How this produces a high voltage. How they've shown this. I don't get it. So let's look at this part number 405. E250 C50. 405. Part 405. Part 405. 405. It's the selenium. Selenophilactic richer. 250, probably 250 volts. I don't know what any of this means. 50? I don't know what that means. So we just need to put in a diode that has a reverse withstand of at least, they're saying 250 here, but didn't it show right on the schematic? It's more than 250. Didn't it? Didn't it show right off of here? 245. Wow. It's 50 milliamps. Yeah, you need something with a much higher withstand than what they're showing here, I think. Anyway, I'm going to pick a diode to go in there. 50 milliamps is easy, and the fact that it's germanium. Is that what I saw there? What did I see? I'll look again. 405. Selenium. Yeah, I'm not going to put a selenium rectifier back in. I will put in a, I don't think it matters, I'll put in a regular one that'll never fail again. I believe one of the important things we need to do in our lives right now is get used to using AI and the numerous subsequent things that are coming at us, like lightning bolts when it comes to this kind of technology. So for my own sake, as soon as I think of it, I start using the Bing system, simply because of the browser I'm using. It makes it convenient. So I want to find the right diode to use. So here's the series of questions I went through. I think you might get a kick out of this. So I said to Bing, Bing AI, Copilot's what they call it, I need a diode that can carry 200 milliamps and withstand 500 reverse volts. What kind can I use? Okay, he's always very optimistic. Certainly, for your requirements, you can consider using Schottky diodes. Let's break it down. And it goes through here and recommends a specific diode. It's not at all appropriate. It's got the wrong voltage to it. Okay, that didn't work. So then I said, how about from the 1N class of diodes? I got this answer. Certainly, the 1N class of diodes typically refers to standard rectifier diodes. Let's explore some options. The 1N400X series, these are widely used rectifier diodes with different suffixes. They have a forward current rating of 1 amp and a repetitive reverse voltage rating of up to 1,000 volts. However, they might be overkill for your requirements. Look, they cost 3 cents, so come on. Then it says a 1N4148 signal diode, 200 milliamps, 100 volts. Again, recommends the wrong thing. So finally I said, just list the 1N class of diodes and their ratings, and I got this table out of it. And so I can just pick through and pick my own. Now I could have probably found this table quickly by just asking for it in the usual Google search, but this is the approach I'm taking. I'm trying to make sure I'm on board with the AI stuff, which is barreling down at us. So if we want to get like 400 reverse, I do a 4. I could do a 5 and get 600, and that would be plenty. So maybe look for a 1N4005, a 5. Okay, a 5. Here we are, right there. Bingo. I have 2 of them. Could go up even higher. That's a 1. That's a 7. I got 2 of those. I'll use one of these. This will be good. This little guy will do the job. Now the next challenge for me is getting the polarity right. I have a amazing ability to get things backwards. Don't know how. So 1, 4. Wait a minute. This is not what it said. What? 140005. Yeah, that's what it is. Okay, so I got to get the direction right on this. Luckily, the actual diode symbol image is written right on this one. So I can just tell from this how this was put in. Okay, we're going to get that diode in there and see if that stops the fire. Okay, diode is in. Now, we could ask the question, so why did the diode fail? Did something cause it to fail? And I think the answer is no, it probably failed on its own. That's a reasonable notion until we for some reason believe otherwise. So I'm going to put this in here. I'm going to stick the back on it. What do we do about this? Still have these horrifying capacitors in here. But I think we want to find out if it's a burner or not. Now if I put the back on, we're not going to be able to see it. I got to find one of these cords. I've got some around. So I have a cord I can plug in and plug this radio in, but the cord is uncontrolled in terms of which way I plug it in. So I could put the live here, or I could put the live here. Now, is there an implication? Well, I think there is. If I put the live here, then the live is going to be all over the chassis ground. Now I'm using an isolation transformer, so in fact this doesn't actually matter right now, so I really probably shouldn't worry about this, but I thought it'd be worth looking at anyhow. Notice the switch is a double pole switch, which is a little bit unusual. So when the switch is open, you're cut right off completely here. That's unusual. Okay, I think I'm ready to try this out. This will be the first time operating this radio, so again I can't control which way this is going. As I'll put it words up. Okay, and this is a polarized plug, but it doesn't make much sense in my shop here because the electric system has no polarity. Neither it's an ungrounded electric system. That's basically what it is. Okay, so how to do this and find out quickly that things aren't working out. My thermal viewer here, although I suspect if something else has happened and that resistor heats up again the same way it did, I won't need to look with this to see it. It's going to be pretty darn obvious. Okay, so this is set for 45 degrees, turns the screen red. And of course there's nothing in there. 45 degrees. The hottest thing is 21 degrees. Very good. Okay, so it's going into a dim bulb system too. I'm going to restrict the power a lot, and again that'll slow the heating problem if there is a heating problem. And do I have the radio switched on? Gee, I don't know. Clear my bench there, I'm not careful. So it's on AM, so we're ready to go. And the volume is, oh good grief, the volume was up full. That would have been a little bit exciting. Just making sure I know what I'm doing here. This is tuning, isn't it? Yes, this is tuning for sure. It's one knob. So there's a tone control behind this one. And a volume. Volume right down. Okay, all set here. Get my viewer ready. Now you may not be able to see the red. we don't want to see the red. We might see the red. Here we go. Be nice if I saw a little wee bit. Anything else happening here? So it's not even enough voltage making it to the radio to operate this thing. So it's like 20 volts here. That may not be enough to do anything at all. I don't see any heating up coming. Okay, what I'll do is I'm going to screw in another light in the dim bulb system. Give it more. Did I hear the speaker pop there when I did that? Now this has started operating, but we're at 36 volts. I don't think this is operating properly at 36 volts, but no heating whatsoever happening here. This is a little odd. These are really bright for a little radio like this. So I suspect something is wrong here. Something's probably wrong. So there's my hand. Now wait, how can we be dissipating 25 watts in this radio right now? Okay, so there is something warming up down in this area. Just a wee bit. Down in here. It's a resistor, so we got something going on. But it's not the one that I was concerned about. It's some other resistor. Wow, what do you do here? This thing says 24 volts on this radio now. These bulbs are blazingly. This indicates a problem. For sure. These bulbs should not be this bright. Oh man. 25 watts is being given up by this radio somehow. There's another area. What's this warming up? This can look. My hand is warmer than these things. So let's see, how warm is this resistor down here now? It's at 30, 32, with almost no voltage on the radio. Something more is wrong. Something more must be wrong. But why that one resistor down there? Just trying to be absolutely sure I'm not mistaking what I'm seeing. But it's definitely not the resistor we were concerned about. That's weird too. That's really quite weird. Different resistor heating up. What about that diode I put in? Where'd it go? We've lost track of the diode because it's down underneath. Oh! Something hot here. Something hot here. You know what I think that is? I think that's the power transformer heating up. Okay, let's pull this out. Of course, the power transformer is invisible from here, except for, you know what, a little tiny crack. So when I thought it was a resistor that was heating up, I was seeing the windings of the transformer through the tiny crack. So this is a bad sign. It's a bad sign. Definitely a bad sign. Doesn't mean the transformer's wrecked. Okay, it's warm, it's not so hot I'm going to get burned or anything like that. Well, feeding into a shorted capacitor. We're back to the shorted capacitor story. Let's get this thing here and just see what's going on. Wow, okay, so the temperature of that is 55. This transformer got up to 55 with the radio not operating, the current, the tube's not drawing current. I mean, there's clearly something wrong here. Very clearly something wrong. Well, I kind of knew that right from the start, though. Too much load on the power supply. Failed filter capacitor. Failed diode. Well, I suppose, you know, this could have been overheated and failed. Because maybe this guy can't take it. This little guy could probably take a fair bit of current. How would you approach this now? I think the way I'm going to approach this is I'm looking at the sunshine outside. I think I'm going to stop and carry on tomorrow. I'm going to leave it at this. looks like problem with this capacitor again. I'm going to leave it here though. So thanks a lot for watching, and I'll come in here tomorrow and we'll kind of focus on that capacitor at this point.